Hello and welcome to Champernowne's constant, project Euler 40. An irrational decimal fraction is created by concatenating the positive integers. It can be seen that the 12th digit of the fractional part is 1. If the n represents the n digit of the fractional part, find the value of the following expression. So we're asked to find the constant at d1, d10, d100, d10,000, and so forth. What we can do is we can actually build the solution from scratch by brute forcing it, but then it would be using too much computational power. I mean, in my case, I see nothing wrong with that solution. However, we can do better. What we can do is keep track of the values that have 1 digits, 2 digits, 3 digits, and so forth, and then we can use that to calculate where we need to be by estimating, then using the remainder of the base that we got here for 10 and using that to find the actual solution for this problem. So what I'm going to do is I'm going to try to explain the solution as much as I can, but it's a lot simpler if you were to solve this problem by hand. So what I've done so far is I've created a Java class, and we're going to go ahead and implement this solution, and I'm going to try to explain as much as I can. First, what we need to do is create some private static method. I'm going to call this one constant, and it takes no arguments. The first thing we want to do is we want to go ahead and build the power of tens, and what we can do is that we can exclude the first d1 because it's just going to be 1, and since we're using multiplication here, that wouldn't really matter. So it's going to equal to, and we can use the in-stream, and we can use the range method, and since we're not using the first one, we can start at 1 and at 6, and 7 is not inclusive. And then what we need to do is go ahead and map it. So I'm going to use W for the current value for our increment state, and I'm going to cast this to ends because the math.power returns a double, and we're going to use that to generate our numbers. And we're going to pass in 10 here and W. And then we're going to go ahead and convert this to an array. The next thing I want to do is actually want to keep track of the 1's digits, the 2 digits, and so forth. And it would be better if we create that using a list. So I'm going to create a list here, and so this is going to be a new array list. It could be a linked list if you want as well. And we're going to take in integers. And then we need to go ahead and also import this by hitting Alt and Enter. Next, what we need to do is we know that the first values are going to be 9, right? And so what we can do is we can say list dot add. We could just add 9 away, or what we can do is we can say power, right, and use the first value there minus 1. Next, what we want to do is want to go ahead and generate the rest of the numbers. So we're going to create a for loop here. I'm going to say for var index is going to be equal to 1, index is less than the power dot length index plus plus. The reason we're starting at 1 is because I already exhausted 10 and we want to use the next values. So we want to add this to the list, so we can just do list.add, and what we want to do is take in the power. We're going to take in the data of the current index is going to be at 100 right now, and we're going to subtract that from the previous number, which is going to be 10. Okay, we're going to do index minus 1, and then what we want to do is actually we actually want to multiply that by the size of the previous number, because that's going to be 2. So we're going to do index. We could do integer dot, and then we're going to use the toString and pass in the power here. And we're going to take the index, alright, minus 1, and then we're going to grab the length of that. Let's say dot length. And then what we want to do is add the first numbers that we generated. So it's going to be list dot get. We're going to do index, right, minus 1. So this should give us 90 times 2, right? And then plus 9, which should give us 189. So what we can do here is I'm just going to go ahead and print out the list so we can look at the values, and I'm also going to do that for the array as well. I can use that for explanation, and let's pass in the power of 10, and we're gonna go ahead and return 0 here just to take out the error. And let's go ahead and create main, and I'm gonna call the constant method here. So let's go ahead and run this. Alright, so the first thing we need to do is figure out where we need to stop. We need to go ahead and add all these values up. And if you did this by hand, you realize that you don't need this because it goes over 1000 here. So what we really care about is using just the first 5 numbers. Also, we can skip 10 for this part right here and just use the rest of the numbers for the calculation. Alright. So let's say that we're looking for the value D1000. We know that the value D1000 is going to fall in between 189 and 2889. So what we need to do is take D1000, and we need to go ahead and minus this value here. It's going to give us 811. So what we need to do is take 811, and we need to divide that by the size of the previous number here, because we're looking at a 3-digit number and not a 4-digit number. Then what we need to do is take the difference, which is going to be 811, and we need to go ahead and mod that by the size of this, which is going to be 3, and that should give us a remainder. All right. And what we want to do is that we want to take the division plus the power here, which is going to be 100 minus 1, which is going to give us 99 for a 2-digit number, and you want to add that up to find the next value. Alright, so from the remainder, we can actually use the difference right from the estimate to grab that. So if we're dealing with 10, we know that 100 minus 10 minus 9 is going to be 1. 1 plus 10 is going to be 10, right? However, the remainder from this is going to be what? 1, right? So what we need to do is take the first value of 10 here, which is going to be 1, and that's actually going to count for the value 10. So let's go ahead and build that. I'm going to go ahead here and remove this, and then we can walk through that. First what I want to do is we're going to go ahead and create a for loop. It's going to be index, right? It's going to be equal to 0. I'm going to do index plus 1, right? Is less than the power 10 dot length, because we want to go ahead and skip that last number because it's going to be over 1 million if we add that together. Next, what we want to do is we want to grab the difference. We're going to say difference is going to equal to, we're going to do power index, right, plus 1, and then we're going to subtract that from the list dot get index. All right, so the reason is because let's say we're here at 100, we don't want to use this number, instead we want to use the previous number, right? So that's the reason why we're using this current number here and subtracting from the number below it. All right, and next thing we want to do is we actually want to grab the div, which is going to be the division, and you're going to say this is going to be the difference, right? And what we want to do is we want to divide that by integer, and then we're going to use the toString. We're going to go ahead and pass in the power and the current index. The reason is because we don't want to use this number here, we want to use this number here. So this would be a 4-digit number, but we're calculating it for a 3-digit number. So we're going to use the index, and then we're going to go ahead and use the length of it. So we're going to do dot length. And then next, we want to go ahead and get the remainder. So I'm just going to say rem, right? It's going to be equal to, we're going to do difference, and then we're going to go ahead and mod integer, and do the same thing, that toString, and do a power of 10, use the current index as well, and we're going to use the length of that. And then what we need to do is we need to grab the estimate. So I'm going to say var estimate is going to equal to, we're going to do the div plus, we're going to do power, we're going to use the current index, and we're going to subtract 1 from that. So we're going to get, let's say we're working with 1000, it should be 9999. Okay, So we have this now. So how do we go ahead and grab our estimate? So it means that if we're dealing with the value 10, right, this is actually going to give us the value 10. So it's for us to grab the estimate, it would just be the remainder of what we get here, right? And then we're going to go ahead and try to grab this from a string. We're not going to need to convert this to a string. So we need to grab the first value here. So what we need to do is convert the estimate to a string and then use the remainder to grab that specific value from it. So what we need to do first is keep track of a result value. So I'm going to say the result is going to equal to 1 since we're going to do multiplication here. We're going to say that result is going to times equal to, and then what we want to do is going to use integer dot parse int, and we're going to pass in integer dot toString, and then we're going to pass in the estimate. Next thing we want to do is want to grab the character at the remainder, right, minus 1. The reason is because the remainder is never going to give us the value 0, and we need to go ahead and convert this to a string so we can get the right answer. And then what we need to do is just return the remainder, the result. All right, and this is it for this problem. Next, what we need to do is we need to go ahead and add in a system.out here, and we need to go ahead and pass in the method here. And once we print this out, we should get the answer for this problem. All right. Like I said, I tried to do this problem this way because I wanted it to be easier. Obviously, there's another way of actually working this out by building everything first and then using the mod of how we did here to actually grab the solution a lot more easily. But I thought that this would be a lot clearer and cleaner to understand, since you can always add printout statements to see what's really going on. Alright guys, this will be it for the solution. If you enjoy it, give me a thumb up. If you have any questions, please let me know in the comment section below. If you have any optimal ways of solving this problem, please let me know. I'm always happy to learn new things. I'll see you guys in the next Project Euler video. Have a good day. Bye bye.